Nuclear plants are one of the best ways to generate low-carbon electricity that saves our environment. But why would the United States invest billions of dollars into a power plant even though it requires decades of labor and faces many unexpected challenges? This plant is known as the Vogtle Nuclear Plant, and it is so innovative that it might solve America's biggest problem. So let's discover this multi-billion-dollar nuclear power plant, its construction, and what are some of the biggest challenges it's facing. Don't forget to subscribe and ring the bell icon for more videos like these. What is the Vogtle Nuclear Plant? The Vogtle Nuclear Plant has been under construction for over a decade due to the many challenges it has faced throughout the years. The initial planning started in the late 2000s when the plan was to make the giant nuclear plant in Waynesboro, Georgia. This plant was also supposed to expand the existing Vogtle electric generating plant until they faced some of the most significant difficulties. It is a 4-unit power plant located in Burke County and has a capacity of a whopping 4,536 megawatts. This makes the Vogtle Nuclear Plant the biggest nuclear power plant and the largest source of low-carbon electricity. Moreover, this plant is also the second largest plant in the history of the United States. But why is it called Vogtle, and why was there a need to implement such a complex naming scheme? You see, the power plant was named after a former Alabama Power and Southern Company board chairman named Alvin Vogtle.
During the Second World War, he was a pilot flying British Spitfire planes in North Africa.
Alvin Ward Vogtle was an American lawyer, a business executive, and a World War II pilot born in Alabama. So it only makes sense to have the name of the power plant against one of the most influential and important figures in American history. But that's not where it ends. The power plant is built in units, and during the construction, we received many challenges that halted the plan for months and sometimes years. So let's talk about the units. Unit 1 and 2 are 4-loop reactors that look quite similar. Like most North American nuclear power stations, each Vogtle unit is constructed with a steel-lined concrete cylinder that is pre-stressed and post-tensioned. This specific model was designed by the Los Angeles Regional Office of the Bechtel Corporation. But what are the specifications of these reactors, and how do they help power plants in energy production? In 2008, reactors 1 and 2 increased in power by 1.7%. Both units can be compared to giant kettles, which boil water to create electricity for homes and businesses. Each unit has a pressurized water reactor, or PWR, which simply means that superhot water is pressurized to create steam. Inside the core of these units, there are special fuel rods that generate heat. This heat boils the water, and even though the water goes through such an extreme temperature, it never makes direct contact with the rod. Combining the two units together, they can provide electricity to hundreds of thousands of homes, and some speculate that it could be up to 600,000 homes. But during all these years, there have been many issues with the first 2 units, even causing the second unit to shut down. That's where the need for the next 2 units came in. It was 2006 when Southern Nuclear Energy formally applied for an early site permit. This permit was for the establishment of 2 new units because they'd already seen a loss in energy due to the previous ones. Moreover, in 2008, they even submitted an application for a combined construction and operating license. Finally, in April 2008, the Georgia Power Company came to terms that they could now build 2 AP1000 reactors that would be designed by Westinghouse. These power plants are unique and aim to lower capital costs and improve the economy of nuclear power. This power plant is owned by Toshiba, and Westinghouse is partnered with the Shaw Group. The Stone & Webster division of the group was to manage the project with Westinghouse, which was responsible for the engineering, design, and other technical details. But that's where things got interesting. This contract initially represented the first agreement for a new nuclear power plant in the US since the famous 3 Mile Island accident in 1979. However, the construction for the AP1000 reactor, or the Plant Vogtle, commenced in 2013. The AP1000 reactor is popular due to its safety-enhanced features. But there's more than just safety when it comes to this advanced piece of technology. It is a pressurized power reactor designed to generate 1,117 megawatts of electricity. It is an improved version of the existing AP600. While the AP1000 has a similar size to the AP600, it has more power. And if the design of the AP1000 made you curious, you'd be stunned to know that there are currently 10 of these units that are either being designed or operating around the globe. 4 of these reactors are in China and are all connected to the grid since 2019. The whole gist of using the AP1000 design in power plants is that it will use the existing components while making the power plant safer and more efficient. It reduces many reactor-related issues, such as valves, piping, pumps, control cables, and more. Used fuel from the AP1000 can be stored on site, in water or even dry cask storage. The design is so unique that it dissipates heat, avoiding all the nuclear-related accidents that could potentially come in the future. This heat can come from radioactive decay products, even after the reactor has been shut down. And to achieve this cooling, the AP1000 uses Westinghouse's cooling system. This system incorporates a water tank above the reactor. When this system is activated, the water simply flows by gravity and then evaporates at the top to remove heat. All in all, the cooling system is one of the most innovative engineering marvels of the Vogtle Nuclear Plant. But construction is where everything changes. In 2009, the Nuclear Regulatory Agency extended the licenses for both old units. This gives the company leeway till January 26, 2047 for Unit 1 and till 2049 for Unit 2. But during construction, something crazy happened. The first 2 units face a significant increase in estimated cost. It went from $660 million all the way up to $8.7 billion, which is just insane. Not only did it cause many construction delays, but it also changed the course of the plans. By 2022, the cost will have become a total of $18.7 billion, which shows how difficult it is to make a nuclear plant sustainable. But that wasn't enough to cater to the ever-changing needs of the nuclear world. The construction of Units 3 and 4 started in 2009. As we've already discussed, the Unit 3 will provide more than 500,000 homes with the necessary energy. But there's a catch. This energy, the delivery, and the unit wouldn't produce any greenhouse gases that could harm the environment. This is one of the biggest milestones the US has ever seen, since now they can produce energy without having to worry about damaging the ozone layer or causing pollution. The spokesperson from the Nuclear Regulatory Commission, Scott Burnell, says there hasn't been a new nuclear reactor since 1996, and now the world is changing. The construction process of Vogtle 3 and 4 was unlike that of its predecessors. But just like the previous reactors, it faced delays as well. These 2 units were initially estimated to cost a whopping $30 billion, and while the company was projecting the completion date to be 2017, there were infinite delays. From complicated regulations that needed to be followed, to something like less labor or cost overruns, the project wasn't easy to make. The regulations were all due to the 3 Mile Island accident in 1979. However, despite all these delays, Plant Vogtle is still on the rise and finally finished on April 29, 2024. Unit 3 was commercially operating in July 2023, but now with a huge capacity to produce electricity, things are looking much better. From the graph, you can see the annual nuclear power capacity of the US was on the rise in the 1970s and 1990s, but after the huge disasters, things stopped. Now we're in 2024, when the 4th unit is active, making a rise, and we've already produced 1,114 megawatts of electricity in a single week. Both the Units 3 and 4 use a new reactor design, which will take a huge toll on energy wastage. To put things into perspective, Units 3 and 4 are projected to take 1 million cars off the road every year. Of course, this is just an example of how much carbon we're going to save from getting emitted. The Plant Vogtle is the perfect example of how we potentially save the world from issues like global warming, while producing the most electricity that we can. The project is still developing, and we're yet to see huge improvements. But over time, Plant Vogtle is going to change the US and provide millions with electricity. If you liked our video, make sure to subscribe and ring the bell icon for more.